We can also graph using transformations. So the graph of a function of the form y equals a times b times x minus h to the n plus k is obtained by applying transformations to the graph of the general polynomial function. And we worked on those earlier in the year. So n is just going to be a natural number. So if it's going to be a polynomial equation, then it could be raised to the second power, or the third power, or the fourth power, etc. The effects of changing parameters in a polynomial function are the same as the effects of changing parameters in other types of functions. So first parameter, k, if we add something to y, it moves it up and down. If we add something positive, it's up, something negative, it's down. Unless, of course, it's on the other side of the equation, because we'd have to add the opposite to move it back. H is added to x if it's, and remember there's a negative with the equation, so if we see x minus a negative h, if we see x plus h, that's the same as x minus a negative h, and it moves it left. If we see x minus h, it moves it right. We can have a vertical stretch if we have a coefficient in front of the entire function. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. And we can also stretch and compress horizontally. It's reversed, though, for horizontal. So if we have a coefficient on x inside the operation, so in this case, the operation would be raising to a power. So if b is inside those parentheses and is a coefficient on x, if it's greater than 1, it's a compression. And the factor would be 1 over b. If it's between 0 and 1, it's a stretch. All right, so we can do each of these transformations. And the best thing to do is to just figure out take your base graph, the points on your parent graph, and then adjust those to match. So this one, I believe, is in the notes. We want to graph, use the graph of y equals x cubed to graph y equals negative 2 times 4 times x minus 1, all cubed, plus 3. So the negative 2 is not cubed. Of course, the plus 3 is not cubed. But the 4 and the x minus 1 are cubed. It doesn't mean we cubed the 4, but it does mean since it's inside that operation, that cubic operation, it means that 4 is on the x value. All right, so the 4 is on the x, the negative 2 and the 1 is on the x, and the negative 2 and the 3 are on the y. I'm going to write this a little differently. I think it's easier to deal with all x and then deal with all y. And this may be in your notes already, so we're just going to change it a little bit. So the x, actually we can leave this first one up because that does go with x. But let's, instead of this, let's put the x minus 1 here. And then we can deal with the y. Here we've put the x and so the x and the y coordinates are listed together in this first column. All right, so we'll deal just with the x, and then we'll deal with the y. So to the y, we have the multiplying by negative 2. So this would be negative 2y. And since we don't need this much space, let's divide that into 2 columns. And then to the y is also the plus 3. All right, let's just deal with all x, and then let's deal with all y. And just remember, our x's and our y's are in the same column in the beginning. All right, so we have y equals 4x cubed. We're going to multiply all our x values, right? Because this is inside the parentheses there. It's to the x. We don't multiply it by 4. We multiply it by 1/4. So this is essentially 1/4 times x. So we're just going to multiply all x values by 1/4. So now we would have negative 2/4, which is negative 1/2. We would have negative 1/4, because 1/4 times negative 1 is negative 1/4. This one won't change. This will be a positive 1/4 because this would be 1 times 1/4, and 2 times 1/4 is 1/2. So we better change the scale or we're going to have, you know, a really skinny graph. And then we're going to, so x minus 1 means we add 1. So negative 1/2 plus 1 would give us a positive 1/2. All right, so we're adding 1. I'm just going to put in parentheses here, plus 1. All right, so negative 1/4 plus 1, all right, that's going to be a positive 3/4, because it's like 4/4 minus 1/4. 0 plus 1, that's the easy one, that's 1. 1/4 plus 1, that's 4/4 plus another 4th, that's 5/4. And 1/2 plus 1, that's 3/2. All right, so this is going to be our x values. Man, that's a skinny graph. And then our y values are really stretched out. To our y values, so that negative 2 in front means we're going to multiply all our y values by negative 2. So your y values are over there, the negative 8, the negative 1, 0, 1, and 8. So this is going to be negative 8 times negative 2 is a positive 16. Negative 1 times negative 2 is a positive 2. 0 times negative 2 is still 0. 1 times negative 2 is a negative 2. 8 times negative 2 is a negative 16. And then we'll add 3. So this would be 19, 5, 3, 1, and 13. I hate to change one scale and not the other, but I don't think we have a choice because the x's are very tiny values and the y's are not so tiny. So I hate to change the scale here. It's going to distort our graph a little bit, but we don't have too much of a choice. Because I don't, well, you know what? Let's just change it a teeny bit, and then it won't look so bad. So let's just make 2 lines be 1, all right? So that each line is a half. So we've just kind of stretched out our x. Oh, we're going to leave the y values alone now. So every 2 boxes will be 1, but we're not going to change this at all right? So this is just going to stay just the way it is. Oops, there should be negatives there. So this would be 1 and this would be 2. So we can fit them as many points as we can on the graph. We won't change the y at all, and we'll not change the x too much. All right, so we're going to graph our points. This is our x right here after we added the 1, and this is our y. So we're going to graph the point 1/2, 3. So 1/2 would be here, and then 1, 2, 3. I graphed the right one. Wait, I'm sorry. My eyes went down. It's 1/2, 19. Well, we can't fit this point on here, so we're going to cancel this point. We can probably, oh, this should be a negative 13. Excuse me, negative 16 plus 3 is a negative 13. We can graph these points, but we're going to leave the 19 off because he doesn't fit. All right, so I'm going to graph in blue so you can see it. So, sorry, we're going to leave off the first point. So 3/4, so that's going to be halfway between the 2 lines. And then 5. So 1, 2, 3, 4, 5, right there. And then we have 1, 3. And if it makes, I'm going to do this just so I can focus. 1, 3 would be here, and then 1, 3. And then 5/4, that's 1 1/4. So that's halfway. Halfway between the 2 boxes, because this would be 1 1/2 right here where I'm tapping. So 1 1/4 and 1. So that's going to be right here. It's still a skinny graph, but at least it's not too bad. 3/2. So that's going to be 1 1/2. So right here, and then negative 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so, man, this is one skinny graph. Oops. Sorry, that wasn't a point. It is a cubic function, but it's so skinny. Let's hope our next graph is not so skinny, but that'll be on the next video. So here with transformations, we can only do it if we've got it written in a form where we can simply transform a parent graph. But with transformations, rather than finding our x and y intercepts and turning points, we can take the parent graph and just move it. All right, so in the next video, we'll do one more. Thanks for watching. Bye for now.